Guys, in this video we are going to learn about the atomic structure and how to calculate for each of the subatomic particles. So let's start with the atomic structure. The atom is composed of two different regions, the nucleus and the electron cloud. The nucleus is the center of the atom that contains the mass of the atom. Now you may remember from previous classes that the nucleus is composed of both the proton and the neutron. Now as the electron cloud states on its name, it's made up of electrons. Now the electron cloud is the region that surrounds the nucleus, and it contains most of the space that makes up the atom. In other words, the electron cloud accounts for the majority of the volume of the atom. So let's start with the proton. The proton is a positively charged subatomic particle. It is equal to the atomic number of the atom on the periodic table. So we can deduce from that information that the number of protons helps us to identify the atom. So as long as you know how many protons there are present in an atom, you can easily identify what that element is going to be. So for example, we know that carbon has a total of 6 protons. And we also know that carbon's atomic number is 6. So if you ever are given a question where you are told that there are 6 protons, look on the periodic table, figure out who has atomic number 6, and that way you can then figure out, well, that would be carbon. Now, up here in the top of the screen, you have the relative size. What that is going to represent is going to be if you were to compare the size of a proton, a neutron, and an electron, we would designate the value of 1 to the proton. Neutrons, as you can see here on the diagram, don't actually have a charge. That is because they're neutral, so they don't have a charge of 0. Now, here on the screen on top, you are also told that the relative size of a neutron is 1. So from that information, we can deduce that both a neutron and a proton are roughly the same size. How do we determine the number of neutrons? Well, if you remember, the atomic mass is made up of two things, the protons and the neutrons. And we know that the atomic number is how many protons there are present. So if we were to take the number of protons away from the atomic mass, right? So we're trying to take this number from here, what would we be left behind with? Just the neutrons. And that's exactly what is happening here. So in other words, if we want to know how many neutrons there are present in an atom, we would have to take the atomic mass found on the periodic table minus the atomic number of that same atom, and the result would be the number of neutrons. Now, you might recall from ever looking at a periodic table, a lot of those numbers are not whole numbers. Well, we'll learn about what that means later on. But for right now, anytime you conduct this equation right here, so this subtraction, just make sure that the atomic mass is always rounded. Because we can have, let's say, 12.01 of an atom, right? So this right here, if we were to do this calculation, we would determine that this just equals to 12 for the mass. And we'll look at an example later on for this. The last one we have to look at is the electron. The electron, as it shows you here on the diagram, it's a negatively charged particle. It is going to have a relative size of 0.00054. So remember, the proton and the neutron were 1 each, and the electron is a very small decimal number. So that should tell you that in comparison to the proton and the neutron, the electron is a very, very, very small subatomic particle, which helps you also to realize that, if you remember from the very beginning of the video, the majority of the mass of an atom comes from the proton and the neutron. And if you think about the size of an electron, its mass is very, very small and therefore is negligible. Here on screen, we also have some information that says the electrons are equal to the number of protons. And that is very important to remember. In a neutral atom, meaning it doesn't have a charge, we know that the protons and the electrons are going to be the same. And think about it. We're saying that an atom is neutral. And therefore, what you can think about that in a way is, well, if the protons are positive and the electrons are negative, and we know that an atom is neutral, meaning it has no charge, well, the positives and the negatives must equal to each other, right? And that's what we have here in this small information. The E, negative, which is the electron, equals to the number of protons, which equals to the atomic number. But remember, that is only true when we have an atom that is neutral in charge. So overview. If you want to change the type of the element, you would change the amount of protons, which we really don't want to do that, right? Because you don't want to change the element. If you want to change the charge of an atom, you would end up changing the electrons and even the protons, right? But technically, remember, if you change the protons, you change the element. And you don't want to do that, right? So we really can only change the electrons. Now, what if we wanted to change the mass of an atom? Well, remember, the mass comes from two places, the neutrons and the protons. But again, you can't change the protons because if you do, you change the element, right? So we don't want to change the protons. So what's the only thing left to change the mass of an atom? The neutrons. So hopefully this kind of helps you get an idea of the subatomic particles and how to calculate for them. Okay, so now let's look at two different examples for calcium and bromine, and we are going to determine how many protons, how many neutrons, and electrons each of them has. So we know, based on our prior knowledge, that the protons and the electrons are going to be the same quantity. So once we figure out protons, we know electrons. And again, that is only for atoms that are neutral. You might be wondering, how would I know? Well, I would give you enough information for you to determine that. Or it would have a symbol right here of a positive or a negative, okay? But here, since we don't have that symbol, we can assume that these two elements are neutral in charge, okay? So let's start with the protons. And actually, let me first erase these two. So for the protons of calcium, calcium on the periodic table is atomic number 20. So we know that the protons for calcium would be 20. And therefore, electrons would also be 20. Its atomic mass of calcium on the periodic table is 40.078. And remember, we said we have to round those numbers because we can't have 0.078 of a proton or a neutron. So we have to deal with full numbers, right? So here, if the atomic mass is 40 minus 20, right? Because we have to subtract from the atomic mass the atomic number, we end up with 20 as well. So calcium has 20 protons, 20 neutrons, and 20 electrons. Now let's look at bromine. Bromine has atomic number 35, and therefore we can assume then that it has 35 protons and 35 electrons, again, because it's a neutral atom. Now for its neutrons, we have to look at the atomic mass. And bromine has atomic mass of 79.904. So we can't really have 0.904 of a proton or a neutron. So we have to deal with the whole number, and we would have to round that to 80. So now we can do the subtraction. 80 minus 35, which is the atomic number, right, would give us 45. So that tells me then that bromine has 45 neutrons. We will look at a few more examples later on in class, so make sure that you review this material and then you complete your assignment on Schoology.